In today's video, we will observe the voltage and current waveforms when a resistive load is energized by a DC voltage source using a MOSFET, which will be fired by these PWM pulses. So let us start. Now before moving into the video, let us observe the waveforms obtained by a block named pulse generator. Let us open the model that we built in the previous video and add a pulse generator from the Simulink library browser. We will use the same frequency of 20 kHz as we used in the previous model. To apply this frequency to the pulse generator, input 1 divided by 20,000 in the period field and just keep 5% as duty cycle. Now let us double click the scope to open it and go to its parameters and make the axis 3 instead of 2. We will observe the pulses from the pulse generator and the pulses from the previous model kept side by side. Let us run the simulation and observe the scope. We will adjust the axis range for better viewing. Let us change the duty cycle of the pulse generator to 40% and run the simulation again. As we can now see, the pulses of both the models are exactly the same. From now onwards, we will try to use a pulse generator instead of the comparator arrangement that we used before. So, for the simulation in this video, we will use the pulse generator and will delete the previous arrangement. Let us add components for the simulation. We will start with the DC voltage source. Then we will add MOSFET. Then for load, we will add the series RLC branch. We will then add voltage measurement for getting the voltage profile across the resistive load. Also, we will require a current measurement block to obtain the current profile. Now in the Simulink interface, we will first obtain an R load of 50 ohms from the RLC branch. Let us disable the measurement port of the MOSFET as it is not required. We will connect the MOSFET in series of the R load and the R load will be connected to the DC voltage source via current measurement block that will obtain the current profile of the circuit. The voltage measurement block will be added in parallel to the R load to obtain its instantaneous voltage and project it to the scope for visualization. We will input the PWM pulses to the MOSFET and scope will be given the PWM pulses, voltage measurement and the current measurement signals. Now let us run the simulation and adjust the access properties. There is some error in the simulation. We have not adjusted the model configuration parameters. We will go to the model configuration parameters in the simulation menu and we will select the fixed step size option, and the step size will set as 1⁻⁻⁷. Also, we will need to make some changes in the Power GUI configuration parameters. In the configure parameters of the Power GUI, we will select our sample time the same as the fixed step size, that is 1⁻⁻⁷. Let us run the simulation again and adjust the access. So now it is appropriate. Now from the waveforms we can make out that the DC voltage source is only getting connected to the R load until the MOSFET is turned on via PWM pulses. Here we can see that the PWM pulses are high and the voltage across the R load is 100 volt and the current is 2 ampere. In the region where the PWM pulses are 0, the voltage across the load is also 0 and also the current in the loop is 0. The voltage across the R load and hence the current in the loop is proportional to the duty cycle of the PWM pulses. As we increase the duty cycle of the PWM pulses, the duration for which the MOSFET remains turned on also increases. This in turn increases the output voltage across R load and also the loop current. Hence, one can say that the current and the voltage across R load can be controlled by controlling the duty cycle of the PWM pulses given to the MOSFET. So that will be for today's video, guys. In the next video, we will see how an inductor will behave in this circuit when placed in place of resistor. Thanks for watching. Drop a like if you found this video helpful. Leave a comment if you have any query regarding the topic, and don't forget to subscribe and share this video with others.